Hello everyone, welcome back. In today's video, we are going to learn how to create a series from a list, a NumPy array, or a dictionary. So first of all, we are going to create a series from a list. First of all, this is my list. This is the list of integers. It has 5 elements, 10, 20, 30, 40, and 50. And these are the indices A, B, C, D, and E. So we are having 5 elements with 5 indices. Now I would like to create my series. I call it series underscore list. In order to use the series function, we need to use it from the series function of the Pandas library. So in order to create the series, I call the series function from the PD, and we assign the data to be equal to data list. So our data equals the data list. So the list of our data that we created here. Okay. Our index equals the index list because we're having already a list. We could also put this one. We could also put this one here. It's optional. But in order to keep the code clean, we can create our list, data list, and index list separately and simply write down the name of the data list and index list here when creating the series using the series function from the PD library. So we are having the index equals index list, and the data type is integer. So we write down d type equals int, and the name of the list we can name it whatever we want. I choose to say list series, and this is basically how our series is created from a list, a data list with its corresponding indices. And we are going to then in the next line print it in the output. So when we look at the output, we see that series from list, exactly this message, series from list, A as the value 10, B 20, C 30, D 40, and E 50, exactly as we were having here. So A 20, 20, A 10, sorry, 20 B, 30 C, 40 D, and 50 E. Then we are seeing that the name is the list series, exactly what we chose here. And also we are having its data type, which is integer. So this was the first part. Then we move on to creating a series from a NumPy array. In order to create a NumPy array, we can use the array function from the NP library, which is the NumPy library. We call it a data array here. Okay, so we call it data array. And we are going to have these elements from 100 to 500. So these are the elements of my NumPy array. Then I would like to index them as well. So I like to have the indexing from uppercase A to uppercase E. Then we have the index array with these labels. Okay, so we created a data array with these elements and the index array with these labels. Then we are having the creation of our series. We call it series underscore array. I call the series function from the PD library. I assign data to be equal to data array that we created just now. Then I have the index equals index array, that is A from A to E. The data type is integer and we give it a name, and the name is array series. In the next line, I'm going to print this series underscore array. So when I run the code, we see this is my series created from the NumPy array. So A 100, B 200, C 300, D 400, and E 500. And the name is array series, exactly like the one that we chose here. And the data type is integer. Now, let us talk about creating a series from a dictionary. In order to create a dictionary, we know that the dictionary is a key value pair. So this is, for example, the first key, and this is its corresponding value. This is the second key. This is its corresponding value, Z, and this number. So this is the dictionary called data underscore dictionary. And these are the keys X, Y, and Z, and these are the values 100, 1000, 2000, and 3000. Okay, so now we would like to create our series from this dictionary. We name it series underscore dictionary. We use the series function from the PD library. We assign the data to be data underscore dictionary that we created here. So here we don't have to have a separated index dictionary for the keys, because index is automatically taken from the dictionary keys. So when we are creating a series from the dictionary, we don't have to have the indexing, because here, for example, when we were creating a series from the NumPy array, we were having the data and indexing, okay, and indexing. Here we are just needing the data, because index is automatically taken from the dictionary keys, which are X, Y, and Z. So we only assign data to be equal to data dictionary. Then the data type, we know it's integer, and we give it a name, which is dictionary series. And then we are going to print this dictionary series. And we see here we are having X, it's 1000, Y is 2000, Z is 3000, and the name is dictionary series, and the data type is integer. So finally, we are going to learn how to create a series from a scalar value. Our scalar value is 99. So we are having a single scalar value, and we would like to create our series from this scalar value. So we name it series underscore scalar. Then we use this series function from the PD library, and we are having data equals scalar underscore value, which is this variable, which is 99. And then for indexing, we didn't create an index, for example, array separated here in the code. We are directly creating it and using it in the series function. So index equals 1, 2, 3, meaning that we would like to have three values for these three indices. Then we are having the data type, which is integer, and then we are having the name of this series, which is called scalar series. And then we are going to print it in the output. So we see that for index 1, we are having 99, for index 2, 99, index 3, 99, and the name is scalar series, and it's of integer data type. So here we learned that even with a single scalar value, we can have three elements here. You see a series with three elements, and because we were having three indices here, we realized that okay, we would like to have three elements using the same scalar value. So in this video, we learned how to create a series from a list, from a NumPy array, from a dictionary, and also from a scalar value. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to learn how to access elements using index labels and positions. So first of all, we would like to create a series with custom index labels. So this is our data list containing from 10 to 50. And this is my index list, which is having A, B, C, D, and E. So now I would like to create my series called series underscore list, and I use the series function from the PD library. Data is assigned to data list, which I created here. Index is assigned to index list that I created here. The data type is integer, and the name is example series. So here I created my series from the list, and we are first of all printing this series. So we see that this is my series. This is the original series. For the A, we are having 10, B 20, C 30, D 40, and E 50. And the name of the series is example series, and its the data type is integer. So we see that we can create a series with a custom index labels. Now, how can we access elements using the index labels? In order to do that, first of all, for example, we would like to access a value at label A. So here we saw that label A was for 10, B for 20, C for 30, D for 40, E for 50. But how can we now access values at label A from this series list? In order to do that, we need to write down the name of our list, which is series underscore list dot. We are going to use this function look. It comes from the location to access elements using index labels. So we write down LOC, and in square brackets, we write down the label of the value that we are looking for, A and C. So the label A corresponds to number 10, label C corresponds to number 30. So I would like to find the value that corresponds to label A and label C. In order to do that, we write down the name of the series dot loc, and in square brackets we write down the label that we are looking for its value. So now we can find the number 10 and 30 in the output because we are using the print function to access these two the values of these two elements, these two labels. So we see that here in the output we are having accessing elements using index labels. Element at index A, it's 10. Element at index C, it's 30. So here also we learned how we can access elements using index labels using the .look function. Then it's also possible to access elements using integer positions. So here we see that in order to access the first element, we write down the name of the series dot iloc, and in square brackets we are having the position or let's say the index of that element. So here this is the index 0, index 1, index 2, index 3, and index 4. We are having it here, as you see. Now I would like to access the element with index 0 and the element with index 3. So you see I'm calling the iloc function for the series list, and in square brackets I have the index 0 and index 3. So this way we can access the number 10 and number 40. We are using the print function to call the value corresponding to the index 0 of the series list using the iloc function. We do the same for the index 3. So when we come here in the output, it says element at position 0 is 10, element at position 3 is 40. So element at position 0 is 10, element at position 3 is 40. So this way we could also, it is possible for us to access elements using integer positions. Now we would like to access multiple elements using index label. So here was how we were accessing the values using labels, but now we would like to do it with multiple elements simultaneously. Again, we use the print function, then we call the lock function for the series underscore list, and there we are going to have multiple labels here, as you see. So A, C, and E. So A, C, and E. So we expect to see 10, 30, and 50. So we are calling multiple values using multiple labels. So when we are having it in the output, we see that accessing multiple elements using index labels, A, 10, C, 30, and E, 50. So we see it here in the output. So this also helped us to learn how to access multiple elements at the same time. Then we can have the access to multiple elements using integer positions. We use the name of the series .iloc, which we used for accessing one element at a time using in the integer positions. So we use the iloc, and then we are having multiple integers position. So we want to access the element at index 0, index 2, and index 4. Index 0, index 2, and index 4. So it's 10, 30, and 50. But we can access them simultaneously here. So we see that here we are having the A equals 10, C is 30, and E is 50, as we see it here. So accessing multiple elements using integer positions, accessing multiple elements using integer positions, A, C, E, 10, 30, and 50. Then we are going to learn about slicing. So we can have the slicing a series using index label. In order to do a slicing, it means that, for example, this is my original series. This is my original series. We're going to have a subset of it. Okay. In order to do that, we can have the print and use the log function for the series underscore list. But here we are going to say start at B, at position B or label B, and end at label D, and they are inclusive. Okay. So start at label B, end at label D. So start at label B, end at label D. It means that we are going to have B, C, D that corresponds to values 20, 30, and 40. So we see that here, slicing a series using index labels, it is having B, C, D, 20, 30, and 40. So this is how we can have the slicing of a series using the index labels. So we are creating a subset basically. And then also we can have the series slicing a series using integer positions. In order to do that, we call the iloc function for the series underscore list, and in square brackets, we write down the positions that we want to include, but we need to be careful because the ending point, which is here number 4, is excluded. So when we are writing from 1 to 4, it means that we're going to go from 1 to 3. The ending point is excluded. So we are going to get elements from positions 1 to 3. So position 1 is here, position 3 is here. Anything that is between them. So 20, 30, and 40. And we see here in the output slicing using integer positions 20, 30, and 40 along with their labels B, C, and D. So in this video, we learned how to access elements using index labels and positions. First of all, we created our series from a list with its index list. Then we learned how to access one specific element using the label, using the index, and multiple elements using labels, multiple elements using indices, and then how to do slicing using index labels, and how to do slicing using integer positions. Thank you for watching. Welcome back. In today's video, we are going to learn how to perform basic operations. So we are going to first of all include the libraries. We are creating a pandas series. So this is my data, this is my index. We use the series function from the PD library and we call it series. The data equals data. So the original data equals this data, and the original indexing in our series equals this index label list. Then the data type is integer and the name of it is example series. So first of all, for the reference, we print the original series. A10, B20, C30, D40, and E50. So we are having it here. Then we would like to perform basic arithmetic operations. In order to do the basic arithmetic operations, first of all, we are printing this in the output. So we see that this is what we are printing here, performing arithmetic operations. The first one, we're using the print function, adding 10 to each element. Okay, it means that the first element is 10. We would like to add 10 to it, so it will be 20. So the second element is 20. We would like to add a 10, so it will be 30. And so it will be 40. This one will be 50. This one will be 60. How can we do that? We write down the name of the series. In this case, the name of my series is series plus 10. So when we run the code, we see that adding 10 to each element is performed. Now, instead of having A equals 10, we're having the label A having the value 20, label E having the value 60. We can change it to any number. We can change it, for example, to 30. So we can add 30 to each element. So if I run the code now, we see that the label A has value 40 instead of 10. Label E has value 80 instead of 50. So basically, this is how we can add add a number to all the elements. Then in the next phase, we are going to do the multiplication. So how can we multiply all the elements by 2? In order to do that, we write down the name of our series multiplied by 2. So here we see that the original series is like this: 10, 20, 30, 40, 50, and everything is multiplied by 2 here. So 20, 40, 60, 80, and 100. We can multiply by 5, for example. If we are looking for something else, we can multiply it by 5. So if I run the code one more time, we see that we are having 50, 100, 150, 200, and 250. Depending on what we are looking for, we can modify this. So this is 2. Then we can do the square. So we can calculate the square of each element. So here is the square. We see that squaring each element is like this. So the first element of the original one was 10. Square of 10 is 100. So the second number was 20. Square of 20 is 400. Square of 30 is 900. Square of 40 is 1600, and a square of 50 is 2500. So we see this the square of elements is being printed here. And finally, if we want to divide each element by a specific number, we can have the series divided by 5, and this is the division label. So we need to have the slash. Series slash 5, it is going to divide all the elements by 5. So the first element is now 2. It was 10. 10 divided by 5, it's 2. Then 20 divided by 5, it's 4. 30 divided by 5, we are having 6. 40 divided by 5, it's 8. And 50 divided by 5, it's 10. So we see that we can perform these arithmetic operations to all the elements of a series. We can do the addition, we can do the multiplication, the square, and the division. Thank you for watching. Welcome back. In today's video, we are going to learn how to filter a series based on certain conditions. So we are creating a Pandas series based on the data and indices here. So you use the series function from the PD library. We call it series. The data in this series equals this data list. Indexing in this series equals the data labels. The data type is integer, and the name of it is example series. So first of all, for the reference, we print it here in the output. So this is the original series: 10 with label A, 20 with label B, 30 with label C, 40 with label D, and 50 with label E. Then we are going to do some filtering. How can we do that? For example, we would like to filter the elements of my series based on the values greater than 25. In order to do that, we write down for series, for the series called series, each element that is larger than 25, we are going to print it. So we see that here for filtering elements, values greater than 25. So values greater than 25, this is this message. We're having C larger than 25, yes, so 30 is being there, D is there, and E is there, 30, 40, and 50. Basically, it was checking like this. So 10, is it larger than 25? No, it's not true, so nothing happens. 20, is it larger than 25? Nothing happens. 30, is it larger than 25? Yes, this is true. So number 30 with its label is being printed. 40 is larger than 25. Yes, it's true. So 40 along with its label is being printed. 50, is it larger than 25? Yes. So we are going to print it along with its label. Okay. So now we would like to filter for values less than or equal to 30. So we write down series, each element that is lower than or equal to 30. Okay, this is the condition based on which we are filtering. So numbers that are lower than or equal to 30, it is going to go like this. So this is the output first of all. It is going to check 10. Is it lower than or equal to 30? Yes, so 10 is there. 20, the second element. Is it lower than 30? Yes, so 20 is there. 30, is it lower than 30 or equal to 30? Yes, so 30 with its label is there. But 40 and 50, these two elements are not lower than 30, so they're not passing this condition, therefore we don't have them here. So values less than or equal to 30, and we are having them here. Okay. Now we can have another filtering example. For example, we can filter for even numbers. So for that series, each element that is divided by 2 and the remainder of this division equals 0, it means that that number is an even number. Okay, so we are going to check if a number is divided by 2 and the remainder of this division equals 0, it means that that number is even number and we want that number. So we are filtering even numbers. We would like to get the even numbers. For this, we are saying 10 divided by 2, the remainder equals 0. Yes, so we are having 10. 20, is it when it is divided by 2, the remainder of this division equals 0? Yes, so we are having 20. The same goes with 30, 40, and 50 because all the elements in my original series, they are even numbers. So if I add, for example, one odd number here, 55, and one label here, for example, F, we see that this new value, that is added to my data list that is going to be later used to create my data in my series, is not an even number, it's an odd number. So when I run the code and go back to this filtering, we see that here we are having numbers from 10 to 50, but 55 is not being printed, which is this number in the original series. Why? Because when 55 is divided by 2, the remainder of this division, is it equal to 0? No, it's not equal to 0. So this statement is not true, therefore we are not going to have it. But how can filter based on odd numbers? If I want to filter based on odd numbers, simply we remove this equal and we assign this. Then we run the code one more time. So these are the values in the original series, 10 to 50 plus 55. And we would like to have the numbers that are divided by 2 and the remainder of their division is not equal to 0. It means that they are odd numbers. And when we are having this condition, we see that here it's not even numbers. We should write down odd numbers here. Sorry. So odd numbers. If I write it down, odd numbers in the series, it's the only one that is 55 that we see it here. So in this video, we learned how we can filter based on certain conditions that we can define ourselves. Thank you for watching. Hello everyone, welcome back. In today's video, we're going to talk about the apply function in Pandas. So it is commonly used to apply a function element-wise to a series or allowing an access in a data frame. Let me illustrate it with an example. So here we are creating our Pandas series. In order to do that, we are using the data list. So we are having 6 elements, 10, 20, 30, 40, 50, and 55. And here are the indices that we are having. For example, A, B, C, D, E, and F. We can call them indices, we can call them labels. For example, for label A, we are going to have the value 10 in our series. For label B, we're going to have 20, etc. until the end, when we are having label F for the value 55. Then we are going to create our series. So the name of my series is this name. This is the name of my series. Series is the name of my series. In order to create that, I'm going to call the series function from the pandas library. I'm assigning data in my series to be equal to the data list. So the right-hand side data is this data list, and this data is the reserved keyword in series. Then index is again the reserved keyword, and for indexing, I'm using the index labels list that we're having here. I would like it to be of integer data type, and its name is example series. So when I run this code, first of all, we are going to see the original series. So this is my original series. You see it here, original series. So label A value 10, label B value 20 until end, F with value 55, and we can see that the name is example series, the type is integer, exactly as we wanted. So the data type is integer, the name is example series. So now we can apply mathematical functions to our series through the apply function. We learned that the apply function in pandas is used to apply a function element-wise to a series. So here I would like to use the apply function for my series. And what is the function that I want to do? It's a square root that I'm using the NumPy library for that. So let me change the name of my series. So I would like it to be, for example, Reza 1. Okay. So here is my series now. It's easier to, I think, provide examples when we are dealing with a different series name. So now the name of my series is Reza 1. So I can use the apply function for my series that is called Reza 1 to perform some mathematical functions. And we know that for using mathematical functions, we need to use different functions in the NumPy library. This is why I'm importing the NumPy library as well. So I am calculating the square root of the elements in the Reza 1 series by using the apply function, and I'm using the NumPy library for the square root. So therefore, this apply function is helping me to have the element-wise operations. Okay, so when we see the output here, we are seeing that this being printed, applying mathematical functions. So this is applying mathematical functions exactly like that. Then we are applying square root function. So here we are having the square root of our elements. So for the label A, the square root is 3.16. So the original number is 10. Its square root is 3.16. The original element, the second original element is 20, and its square root is 4.47. Then for the label C, the square root is 5.47. So for label C, the square root of 30 is 5.47, etc. Until the end, we are writing down the square root of all these elements using the square root function, let's say sqrt from the NumPy library, using the apply function for my series that is called Reza1. Okay, now we can have the logarithm as well. So logarithm is called from the NumPy library using the apply function for the Reza1, and here is the natural logarithm for the elements being labeled from A to F. Then after that, we are having the exponential function from the NumPy library we are using it through the apply function for my series that is called Reza1. And for that also, we see that for example, first element, the exponential function is this one. For the last element is this one, for example. Okay. Then another thing that we can do for our series is to apply custom functions. So in order to apply custom functions, we can have the name of the series. We use the apply function, and then we are raising each element to the power of 2 using the lambda function. Okay, so each element of the Reza1 series is being raised to the power of 2 through the apply function here in this line. And also here in this line, we are printing a prefix value before printing each element in the series. So when we come here, we see that, for example, the double the value is this one. So the first element, sorry, this one is not to the power of 2. It is the x multiplied by 2. If we were having 2 stars, it was like we were raising the value to the power of 2. We are simply just multiplying it by 2. So if we were having 2 stars like this, we were raising it to the power of 2. So when I run the code, now we are raising it to the power of 2. So the first element is 10, 20, 30, 40, 50, 55. So when I run the code, here we see that the power of 2 is like the first one was 10, so now its power of 2 is 100. The second one was 20, now it's 400. The third one was 30, and now it's 900, etc. So this is how we can have a custom function to the power of 2. And if we wanted to multiply it by 2, we could have simply 1 star. Then we would like to have the prefix before the x being printed in the output. So when we were having the prefix, this is my prefix value. So you see that in the previous stages, we were not having any prefixes. But now here I'm having the prefix value. You see, this word value is my prefix. So we are applying a lambda function to convert to string with prefix value. And we are having for the label A value 10, B value 20, C value 30 until the end. And finally, it's nice to know that we can also apply conditional functions. For example, we can mark values as high if they are larger than 30. Otherwise, we are going to mention that, for example, they are low. So I'm using the lambda function from the to perform this condition for the elements of my series through the apply function, which help me to have the element-wise operations. Okay, so here I'm saying that if that element of my series called Reza1 is larger than 30, label it as high. Otherwise, label it as low, meaning that if the value of x is lower than or equal to 30, label it as low. So when I run this code and I come here, we see that the first 3, they are low. The last 3, they are high. So the first 3 elements, 10, 20, 30, they are labeled as low. 40, 50, 55, they are labeled as high. So if x is larger than 30, label it as high, else label it as low. And also we can apply a function that adds 5 if the value is even, otherwise subtract 3. So if the value is even, we're going to add 5 to that. Otherwise, it means that it's it's not an even number and it's an odd number, and we are going to reduce 3 from that in this case. Okay, so for example, the first element is 10. It's an even number. We are going to add 5 number to it, so it will be 15. 20, it's an even number, so it will be 25. 30, it's an even number, it will be 35. 40, it will be 45. 50, it will be 55. But 55, is it an even number? No. So 55, when it is divided by 2, the remainder of this division is not equal to 0, so it's not an even number. It goes to the else part. And here, 55 minus 3, it will be 52. So when I look at this example here, we will see that here we are having the applying a function that adds 5 if the value is even, otherwise subtract 3. So the first element was 10, now it's 15. The second element was 15, was 20, now it's 25. The third element was 30, now it's 35. The fourth element was 40, now it's 45, because they were all even. The fifth element, it was like 55. It was like 15, now it's 55 because it was even and we added 5 to it. And finally, the last element was 55, and it was not an even number, so it was an odd number. Therefore, we subtracted 3 values from it, and it has become 52 now. So in this video, we learned that we can use the apply function to apply for example, the element-wise operations. First of all, we were having the data list and the labels. We created a series from this data list and the labels. Then we learned that through the apply function for our series, we can perform certain mathematical operations, for example, square root, logarithm, and exponential function. Then we learned that we can apply custom functions. For example, we can raise the elements to the power of 2. We can have the prefix being printed. We can apply conditional statements. For example, if the elements are larger than 30, print high, otherwise print the message low. Or for example, here, if it's an even number, add 5 value to it, otherwise subtract 3 value to it. So all of them are, all of this is possible. And we saw that in this example, we can do that. And finally, here we are going to have the user-defined function here. So we can have a function called custom function, and we are going to, when this function is called with one argument x, we are going to check if x is divided by 2, the remainder of this division equals 0. If this is true, it is going to multiply that x by 3. Otherwise, it is going to add 7 to that x variable. And whenever we want to call this function for the elements in my series, we are going to write down the name of the series, which is Reza1. Then through the apply function, we can call this custom function. And this custom function is basically going to perform this mathematical operation over all the elements of Reza1. Therefore, the first element, is it an for example, even number, okay, multiplied by 3 up until the end. So we see that here, for example, we are having the first element was 10, and it is now multiplied by 3, so it's 30 because it was an even number. It happens with all the elements because all of them except the last one are even numbers, so they are multiplied by 3. But the last element was 55, and it was an odd number, and we said that if it's not an even number, add 7 to that variable. So we see that here we are having number 62, which is 55, the original element, plus 7, so it has become 62. So we can also have a user-defined function for our series called Reza1 through apply function. Thank you for watching. Welcome back. In today's video, we're going to work with the map function for this series. So here is my data list containing 5 elements and the labels. And we are creating our series called Reza2. And in order to create that, I'm calling the series function from the Pandas library. I assigned the data of this series to be equal to this data list, and the index of this series to be equal to index labels. And then I would like it to be of integer type, and the name is example series. So now I would like to perform some operations using the map function. The first thing that I would like to do is to convert these numbers that I created in my series, that I initialized for my series. I would like to convert them to strings. And in order to do that, I simply write down the name of my series, which is called Reza2. Then using the map function, I write down str in parentheses, and we see that here in the output, we are having the conversion of numbers to strings. Also, you are here again seeing numbers, but their data type is not integers anymore. They are of type object. It means that they are converted to a string. So in order to convert them to a string, we use the function map, and then for our series called Reza2. And then we can apply a function that labels values based on a condition. For example, here for the Reza2 series, I'm using the function called map, and because I'm defining a simple function, I simply use the lambda keyword to create my function here. So I would say if the value of the element in my Reza2 series is larger than 30, label it as high. Otherwise, label it as low. So these are the numbers 10 to 50. And for example, if 10 is larger than 30, label it as high. Is it larger than 30? No, 10 is not larger than 30. Therefore, we are going to fall into the else part, and we are going to label it as low. The same happens with the 20 and 30. So both of them are not larger than 30. So we are going to label it as low. Then we are having 40 and 50 that are larger than 30, and we are going to label them as high. So when we come and see the result, we see that the first three elements are low, labeled low, and the last two ones are labeled high. Then we would like to apply some mathematical transformation. For example, here we are having the square of each element. For my series called Reza2, I use the map function to have the square of each element. So when I run the code, I come here and see the first element was 10. Its square is 100, so 100 is there. My second element is 20, and the square of 20 is 400. 400 is there. My third element was 30. The square of 30 was 900, etc. until the end. So we learned here that we can also apply some mathematical operations. For example, having the raised to the power of 2. And also, we can apply a function that categorize values into ranges. For example, for my series Reza2, I use the map function to label it as a small if the value is lower than 20, and if the value is lower than 40, I'm going to label it as medium. Otherwise, I'm going to label it as large. So we see that the first element is a small because the first element is number 10. The second and third elements that are 20 and 30 are labeled medium, and the last two elements are labeled large. Why? Because the first element is 10. 10 is lower than 20, yes. So label it as a small. Then we were having the second and third elements because they were lower than 40, and because 20 is not lower than 20. If it was like 20 lower than or equal to 20, yes, we would have labeled it as a small. but 20 and 30, both of them fall into the medium part. Why? Because they are lower than 40. And the rest of them, like the 40 and 50, they do not fall into this range as well, so they are falling in the large part that they are labeled as large, as we see here. Also, we can use map function with a dictionary for value replacement. So here I'm having, for example, a dictionary, and in dictionary we are having key value pairs. So the keys are 10, 20, 30, 40, and 50, and the values are these strings 10, 20, 30, 40, and 50. Okay. Then here in the output, we are having the series called Reza 2 using the map function, and we are in parentheses calling the mapping dictionary that we just declared. So here in the output, we see that these numbers 10, 20, 30, 40, and 50. So these numbers that are in string, they are being labeled from A to E. So we are basically replacing values using a dictionary because the values were numeric here, but we see here they are strings and we replace them using a dictionary. So it's possible to replace values using a dictionary. How? We write down the name of the series, then the map function, and in parentheses we write down the name of our dictionary, and it is going to automatically replace the values. Then we are willing to handle missing keys in dictionary mapping. And for example, here we are having a dictionary called mapping dictionary with missing. Okay, so it has two elements, two keys, let's say 10 and 30, and two values 10 and 30 that are a string. Then we are using a lambda function for my Reza 2 series through the map function, and we are saying that, okay, get the value of x from this dictionary, which is called merging dictionary with missing. So basically it is this dictionary, get the value of x. Otherwise, if there is no value, assign unknown. And when we come and see, we see that the first one is 10, the third one is 30, but the other ones are unknown. But how is that possible? So my series is like having these values 10, 20, 30, 40, and 50. Okay. And my dictionary is having the keys of 10 and 30. Okay, so 10 and 30, you see it here. So it says that for the value, for the key 10, replace its value with 10, which is a string. And then for 30, replace it with 30, which is a string now. So we are here using a function to get the values from this mapping dictionary with missing. And if there is the value there, return the value, which is 10 and 30. Otherwise, return unknown for my series called Reza 2. Okay, for this series, we see that we are having 10, 20, 30, 40, 50, but here we are only having 10 and 30. So these two are there. So for these two, it is going to get the value of the x, which is 10 and 30. For 20, 40, and 50, it is not going to get that. Why? Because there is no value for that. Therefore, it is going to return unknown. So exactly as we see here, 10 and 30, they were there. So it is there. And then the unknowns are also there, as we can see it here. And finally, here it is possible to handle non-values gracefully. For example, we are having a series here that is containing these elements, and the labels are from the index labels list. So these are the labels A, B, C, D, E, and these are the numbers 10, 20, none, 40, and 50. Okay, so there is one missing value there, and we are going to handle them using the map. So I use the map function for this series that is called series with none. Then we are going to say if there is a value there, get that X, otherwise report the missing string. So here it is going to get the value 10, 20, 40, and 50. But for the C, it has no value, so it is writing down the missing message. Why for element C, for label C, there is no, because this one is label A, this one is label B, this one is label C. And for C, we have the missing value. So here in the function, we are checking, okay, if there is any value for the X, return it. Otherwise, report the missing string. So we see that here, because there is nothing there, we are reporting the missing string. So in this video, we learned how to work with the map function for our series. First of all, we learned how to convert our numbers into strings. We applied the conditional for the series. Here we raise the series to the power of 2. Here we were having like another conditional example where categorizing values were discussed. Here we are replacing values using a dictionary. Here we are having a dictionary that is having 2 elements, while in our series we are having 5 elements, so the missing elements are detected there. And also here we learned that if there is any value in for certain labels, we are going to return them. Otherwise, if there is not something there, we are going to write down the missing string label there. Thank you for watching. Hello everyone, welcome back. Here is a table to compare the map function and apply function for our series. So here we see that in terms of scope, maps are element-wise transformations, and apply, when we are using the apply function, we are having the flexible transformations. And the maps are only applicable to series, while the apply function can be applied to series and data frames as well. So here we see that for maps, we can apply a function to each element. And while we are having the apply function, where we can use it to apply a function to elements, to rows or columns. So it's more flexible as we see this apply function. Then for the map function, we know that they can support dictionary mapping, while using the apply function, it's not possible to support dictionaries. And with respect to data frames, I would say the maps are not working with data frames, and they only work with series. While using the apply, we can work with data frames as well. And is it possible to do the row-wise operations using maps? No, they cannot apply functions like row-wise stuff. But for the apply function, we can apply them to row-wise with axis equals 1. And for the maps, the performance is faster for simple transformations. But for the apply function, they are slightly slower but more powerful. So in this video, we compare the maps and apply functions, because in the previous videos we were having some coding exercises with apply function, and we were having some coding exercises with map function, but it was not tangible to see their differences. So we see that we can use the apply function for series and data frames, while using maps we can only apply them to series. And for doing the functions, having the functions to elements, we can use the apply and map functions, both of them. However, we can further use the apply function for rows and columns, while the map function support dictionary mapping. In the apply function, we don't have the dictionary mapping. Okay, so the apply functions are also good for the data frame, but for the map function, we cannot apply them to data frame, and they only are used for series. So, and they are typically faster, but apply functions are a bit slower. So this was a good comparison of apply and map functions. So now we know their differences, and we know that if we are working with a data frame, we need to use the apply function. Okay, if we want to have a function for rows and columns, we are going to use the apply function. Okay, but if we would like to only work with series, or we would like to have a support for dictionary, or we would like it to be faster, we are going to use the map function. Thank you for watching.